In the previous session, we have seen the problems on column space, null space, and just we have seen what is the meaning of means. What do you mean by means? What are the fundamental four subspaces? Means that is column space, null space, row space, and the left null space. Okay, and that we have seen. So now we'll see the problems on the four fundamental subspaces. So start with the find the null space of the homogeneous system with coefficient of matrix A as follows. Okay, so as we need to find out the null space means, as we know, Ax equal to 0. Okay, so this is X here and Ax equal to 0, and this augmented matrix we can write it like this, and after that we need to apply the row operations. Okay, so apply the row operations by including the 0 as augmented. Okay, and next here, so after applying the row operations, okay, now we need to find means finally we will find out the two pivot elements here. Okay, so as it is the two pivot elements, so rank of the matrix is 2 here. Okay, and we have the equations, means the first row, if you see, that is x1 plus 2x2 minus 2x2 x3 plus x4 is equal to 0, and the next one is x3 plus x4 equal to 0. Okay, so now here out of 4 variables we can see that, okay, the first variable and third variable is the base variables, and the x2 and x4, okay, the x2 and x4 are the free variable. Okay, means we can choose x2 and x4 any values. Okay, and x1 and x3 are the base variables. So if we choose x2 value as x and x4 value as t, okay, the same thing we need to apply in these two equations. Okay, in these two equations, so if you replace x2 and x4 with t, then we will get x1 equal to, means first we need to replace in this equation x3 plus x4. So x4 is equal to t, so then x3 plus t, okay, that is x plus t is equal to 0, so then x3 is equal to minus t. So this x3 is equal to minus t and x4 is equal to t and x2 is equal to s, we need to put in this equation. Then we will get x1 equal to minus 3t minus 2s. Okay, so if you write in form of matrix, then we will come to know that is x1 x2 x3 x4. We can write as x1 is nothing but this one, and x2 is nothing but s, and x3 is nothing but minus t, and x4 is nothing but t. Okay, so if you put the values, then we will get, okay, means the s vector, okay, so s variable with a matrix, that is what are the s values. So first row is 2 minus 2, second row is 1, third 4 0. If you take the t, the first row is 3, second row 0, and third row minus 1, fourth row 1. Okay, so this we call as the null space. Okay, the vectors here. Okay, so the null space vectors is this one, so minus 2 1 0 0 and minus 3 0 minus 1 minus 1. Okay, so this is a vector for the null space here. And the nullity, so nullity how we can calculate is the dimension of the null space. So dimension of the null space is nothing but n minus r. N is number of variables and r is the rank of the matrix. Okay, so as we said here, so rank plus nullity, so rank plus nullity is equal to r plus n minus r, that is nothing but n here. Okay, so in this problem, so here we need to find the null space, so x equal to 0. So here we are finding the null space vectors here, the two vectors what we have solved now here. Okay, the next problem, so in this problem we need to find out the rank and nullity. Okay, we need to find out the rank and nullity. Okay, so here, so the A as given, the A matrix is given, and we need to, means we need to row reduced echelon form, we need to go for that, or echelon form we need to go for that. For that we need to apply the row operations. Okay, so we are applying row operations and interchanging the rows and dividing. So after doing all those operations, you will get the finally the matrices, the matrix like this. Okay, in this case 3 pivot elements, 1 2 3 pivot elements, so rank of the matrix is 3 and nullity of the matrix n minus r, n is 5. Okay, as there are the 5 elements here. Okay, so number of elements in this matrix is 5, or number of variables n equal to 5, so n minus r, r is 3, so nullity is 2. Okay, so here what we need to do, the rank and nullity means the same row operations we need to apply until we need to get echelon form or row echelon form, then we need to find out the rank and nullity here. Okay, so after calculating the rank and nullity, so again the next problems, so we'll see here in this problem, the directly, instead of giving directly the matrix, they have given the vectors here. Okay, vectors in terms of, if t, define t is a vector or a vector space which consists of 3 vectors like x y z, which is nothing but x plus y, x minus y, and 2x plus z. Okay, so here we need to find out, so what we need to find out is find the range space, that is nothing but column space, null space, rank and nullity. Okay, so all these 4 we need to find out: column space, null space, rank and nullity. To do that, and also we need to verify the rank of t and nullity of t is equal to dimension of r, that is n. Okay, so to find out that, so we need to represent this in a matrix form. How to represent this in matrix form? So we know that the standard form, the standard basis, okay, for the linear, the transformation. Okay, so we can write the vectors as the standard basis. Okay, you have seen in one of the conditions the standard the basis we can write as 1 0 0 0 1 0 and 0 0 1. Okay, so if you take like this the standard notations 1 0 0, so 1 0 0 you apply these values in these equations. Okay, so 1 0 0, that is x y z, if you take. Okay, so here x is 1, z is 0, and y is also 0, and here x minus y, x is 1, y is 0, and here 2x plus z, 2 into x is 1 and z is 0. So similarly we need to fill the values, so that is 1 0 0 0 1 0 as x y z, and we will get this vector. And similarly the one more the third standard 0 0 1, so we need to apply to this equation and to get the third the vector here. So after getting these vectors, okay, so after getting these vector means, here this is t means the transformation here. Okay, the transformation r3 to r3, the transformation in such a way that the relation is like this: x plus y, x minus y, 2x plus z. To find out the vectors, we are taking the standard basis, that we are helping to find out the matrix. Okay, so now once we got the matrix here, then it is a normal procedure to apply the row operations here. Okay, so if you apply the row operations, then okay, so if you apply the row operations, you will get 1 1 2, 0 minus 2 minus 2, and 0 0 1. So this is nothing but the echelon form. If you see here, the rank of the matrix is 3, means 3 pivot elements. The rank of the matrix is 3. Then range of the matrix, so range of the matrix is nothing but column space. How to find out the column space? The column space is nothing but the whatever the factors are there, so that we call as the column space. Okay, so now if you take the vectors, okay, here they have taken as the horizontal here. Okay, so now the same thing we can write in 1 1 2 0 minus 2 minus 2, okay, and 0 0 1, like that. Okay, so now the same thing if you express in terms of the equation, okay, then you can see here x1 1 here, and here x1 term is 0, and here x1 term is 0, only x1. And if you come to the second one, okay, x1 minus x2, okay, the x1 minus x2, and here the last term is 0, so only means you can say 1 0 0 means only x1 term is here. But if you come to the second term, x1 is there x2 is there, x3 is 0, so only x1 minus x2. If you come to the third term, 2x1 minus 2x2 plus x3. Okay, so this is the three equations what we are getting. So this we call as range of space, or we can call as column space of T. Okay, so now next we need to find out null space. How to find out null space? We know A matrix, okay, then X, and that should be equal to 0. So we can see here. So further you can reduce here, or you can directly the cross multiply. So whatever we got after the reduction, okay, in the previous, the same problem here, same matrix, so directly we have taken here. So now after doing all those things, the row operations will get like this. Okay, but here what we can see here, so x1, okay, what is that, x3 equal to 0. Okay, x3 equal to 0, and even x2 equal to 0, and here x1 plus x2 plus 2x3 is equal to 0, means as it is we are equating to 0 factor. So now as we got here x2 and x3 are 0 0, so x1 also 0, hence so this is means the null space is exist here, means n a, so hence there is a exist of null space for the T. Okay, and here rank already we know that 3, and nullity is nothing but the number of variables is also 3, rank is also 3, so nullity is 0. So in this problem we need to find out column space, the null space, and rank and nullity. So rank is 3, nullity is 0. Okay, and so again here once again they have written, so rank plus nullity. So here individually we have calculated rank and nullity. So rank plus nullity is nothing but, that is 3 plus 0, that is nothing but 3. Okay, so we know that rank plus nullity is equal to dimensions of Rn, that is nothing but n. So n is number of variables is 3, and also rank plus nullity is also 3. So hence we say that the rank nullity theorem is verified here. Okay, the similarly we'll take up the next problem. So here in this problem, so for given matrix we need to find out null space, column space, and the row space and left null space, means all four subspaces we need to calculate. So in the given problem, okay, so apply the row operations and we'll get this problem. Here the number of pivot elements is 2. Okay, number of pivot elements is 2, so rank is 2, and here the column space is nothing but only the 2 column space, because the 2 non rows are there. Okay, the column space is nothing but the linear combination of the columns, combinations of columns. Okay, so if these two rows are, sorry, here if you take here, if these two rows are the bases, then the two columns of with respect to that, what are the columns here, the first and second. Okay, means first and second row means the first column 1 2 3, and the second column is 0 1 1. Okay, so as the first two rows. Okay, or you can say that even like this also, first pivot column, next pivot column. Okay, so these two pivot columns is nothing but the columns is 1 2 3 0 1 1. So because of that the column space of A is 1 2 3 and 0 1 1. So as only two pivot columns are there, and rank of the matrix is also 2. Okay, so column space is over. Now we need to find out, okay, here the row space. Okay, row space is nothing but, so we need to take the A transpose. Okay, A is like this, A transpose is here, again we need to apply the row operations. So finally we are getting the two, what is that, two pivot columns. Okay, so here two pivot columns in the sense, what is the main matrix here, the transpose here, this one. So this is the main matrix in this problem after transposing. So these two columns 101 and the 212, so these are the columns with respect to pivot elements. So that is nothing but the row space of the A, means row space is nothing but the column space A transpose. So as we know the pivot elements, these two columns, then result will be the main columns, that is 101 and 212. Okay, then we need to see null space, that is Ax equal to 0. So we know that A is given, x is here equating to 0. Okay, then apply, means after doing the row operations, so you will get this one. So directly we can say that, so x1 x2 are base variables, okay. Then x3 is free variable because so both are 0 0 here, okay. So then if x3 is equal to t, if I take x3 is equal to t, then x2 is equal to 0 and x1 plus x3 is equal to 0 according to the matrix, this one here. So then the values we will get is x1 is equal to minus x3 is equal to the minus t here, means x3 is equal to t, x1 is equal to minus t and x2 is equal to 0. The same thing we can write here, minus t 0 minus t. So the vector we can say that minus 1 0 minus 1. So if this is a vector, then we will get the, means x1 x2 x3 values are like this, then we will get the 0 vector. So we can say that the given matrix is a null space of T. Okay, then similarly the last one, that is left null space, is nothing but we need to take A transpose. Okay, so whatever A is there, we need to take A transpose into y is equal to 0. Instead of x, they are taking as the y here. Again we need to apply the row operation. After doing that, we got the two pivot elements. Okay, again here the third element is 0. Okay, you can take as third element as s. Okay, similarly like previously, like in null space, so we have two equations here, and replace y3 with s. If we replace y3 with s, then y2 is equal to minus s. That both y1 and y2, y1 and y3, if we replace in third equation, we will get the minus s here. Okay, so the values of y1 y2 y3 we can give as the minus s and s. That is nothing but, if we s to take as outside, minus 1 and 1. Okay, so this is the n A transpose is a span of V here. Okay, so here dimension of this n transpose A of T, that is left null space, is equal to m minus r. So m is nothing but 3. So m is nothing but columns. Okay, 3 columns are there. 3 minus 2, that is 1. Okay, so this is to find out what is that? This is to find out column space, row space, null space and left null space. Okay, those values again, once again we have written here, and the relation between that. Okay, so we need to find out the relation between these four operations, these four subspaces. Okay, so in that case, so what we can tell that the CA and column space and the left null space are, you can say here, the column space, okay, the column space and left null space of that is Na of T. Okay, and the row space, that is Ca of T, and okay, here this transpose, okay, little bit, just one second. Yeah, so what we need to do here, so Ca and Na of T. Okay, Ca and Na of T. So Ca and Na of T, that is nothing but the same thing here, Ca and Na of T. These relation between this is the orthogonal. Okay, to see that that is orthogonal, we need to take a dot product. So as we have seen the earlier, okay, dot product. Okay, so if you take the dot product here, then it is nothing but we need to take transpose of C of A and multiply dot product with the Na of T. Okay, so what is Ca here? Ca is nothing but 1 2 3. Okay, this 1 2 3 we need to take as a transpose, so that will become horizontal 1 2 3, and Na A transpose is minus 1 1. So if you multiply both the things, we will get 0. Similarly, take the next vector 0 1 1. Okay, if you take the next column vector 0 1 1, and again Na of T is the same here 1, so same take thing and multiply, we will get 0. So as we are getting, okay, so why we are taking here transpose in the sense, so the theory u dot v is equal to, actually that is u transpose v, no dot here, u transpose v. So how we need to calculate? So similarly here, to find out the relation between column space and left null space, we need to take transpose of Ca and multiply with the Na of T. So we are getting 0. So hence we call that CA and left null space is perpendicular to each other. Similarly, similarly, the relation between CA of t and NA. Okay, so the previously we have seen CA and NA of t, and now we need to see the relation between CA of t and N of A. Okay, the same method here. We need to take CA of t, transpose of that we need to take and multiply with NA. We will get 0. Similarly, take other factor and multiply with NA. We will get 0. So the standard form, okay, in say that the column space is always perpendicular to NA of t, and similarly always the row space, that is CA of t, is perpendicular to null space. Okay, so this is how we can say the diagram, the relation between the four subspaces: column space, okay, and left null space and the row space. Okay, so these two are perpendicular and these two are perpendicular. Okay, the similarly some other problems. Okay, obtain the four fundamental subspaces. So direct he has not mentioned individually as column space, subspace, column space, null space, row space, like that. So four fundamental subspaces means we should understood. So we need to calculate C of A and C of A transpose, N of A and N of A transpose, that is left null space. So all the four we need to calculate. Okay, so before that, so take the matrix and apply the row operations and find out the echelon form. Okay, so in the echelon form, so we see that there are two pivot elements, so the rank is 2. The rank is 2. Then so directly we can say that there are two pivot form, so directly we can write the column space as column space is equal to the whatever the pivot columns are there, the same two columns we can write as the column space. Okay, that is 1 3 minus 1 3 5 minus 3, the first column, and the second column 3 2 15 minus 2. Okay, the similarly the dimension of CA is rank of matrix, that is already we have calculated 2. The dimension of CA of t, so both are same here, dimension of CA and dimension of CA of t, that is 2, and dimension of NA is n minus r. We know that r is 2 and n is, we know that, so n is the number of variables is 3. Okay, so number of variables is 3, so 3 minus 2 1, and dimension of NA of t is m minus r. So m is number of columns is sorry, yeah, number of columns, so here 4, so m is number of rows, right? M is number of rows and n is number of variables. So m is number of rows, so 4 rows are there, 4 minus 2 2. Okay, the dimensions for each subspaces. Okay, the next one, after calculating column space, we need to calculate Ax equal to 0. So A is given, we need to take x and then take 0 vector. Okay, so after applying row reduced form, so already in the previous page, so directly we can say that, okay, so here only two rows are there, so two equations we can take. Okay, two equations we can take. So here x1 and x2 are base or pivot variables, and x3 is a, okay, so x3 is the free variable here. Okay, x3 is free variable, so we need to write the three equations, that is first one x1 plus 3x2 plus 5x2 and x3 is equal to t, and second one minus 7x2 minus 9x3 is equal to 0. So we need to do back substitution. Okay, so here obtain the okay, also find dimension. Okay, we need to find out the dimension here. Okay, so one more thing here, A is like this, this is U. Okay, so here U is nothing but the augmented matrix. Okay, so they have U is nothing but the augmented matrix, so rank is only 2, so A is given as this one. Okay, okay, so we can apply the row operations. Okay, after applying all these operations, we are getting like this, and we got the two vectors in the column space, and we have calculated the dimensions like this. Okay, and the during null space we need to equal to 0, and after row operations we are getting like this, and there are three variables, so three equations. So assume x3 is equal to 3 t, third variable, and do the back substitution. After doing the back substitution, so you'll get like this, and dimension of null space is n minus r. N is 3, okay, the number of the columns here, so 3 minus 2 is equal to 1 here. Okay, so similarly row space of a we need to calculate by a transpose. So a transpose we are taking like this, and again apply the row operations, and we'll get the matrix like this, and rank is 2, and the two columns, the two pivot elements, the two columns, that is 1 3 5 and 3 2 6. So these are column space, means row space. Okay, that is okay, C of A transpose. Okay, similarly the last one, the null space of, means the left null space, that is n a of A transpose. So A transpose into y is equal to 0 here. Okay, so as here the four columns, okay, so for the variables here it will come, and here in this, after doing the what is this, the row operations, we will get the same matrix here, and 2 y1 and y2 are variables, and y3 and y4 are free variables. Okay, so as we can see here, so why we have taken the three variables. Okay, here is this, I have taken the three variables is the column is 3. So how we will represent the vector equation? It is like alpha x1 plus alpha x2 and alpha 3 x3. Okay, so as it is only the three alphas, alpha 1 alpha 2 alpha 3, okay, the three variables are there. Okay, so here after, if you do the A transpose, then it will be four variables here. Okay, and similarly if you apply the row operations, so as we know, the two pivot elements and two base variables and two free variables, again we need to assume y3 and y4. Okay, so if you do assume y3 and y4, and y3 as s and y4 as t, okay, so we need to apply from the bottom side, that is the minus y2 is equal to minus 7 y4. So y4 we have assumed as t, so this will, y2 will become t, and this you substitute in the first equation, and also y1 is equal to, that is y1 we will get as minus 5s. So we will get the matrix. Okay, so you'll get the matrix as minus s t s t. So you take s and t as separately. Okay, so if you take s and t, so that is the coefficients will live with that is minus 5 0 1 0, that is 0 1 0 1. So two vectors here, the two vectors, that is n a of t is equal to minus 5 0 1 0 0 1 0 1. Okay, the dimension of n, that is n a transpose is equal to m minus r. M is nothing but the number of rows. Okay, so rows here, oh sorry, m is nothing but number of rows, so rows here 4, so minus 4 minus 2 is equal to 2. Okay, you can say, okay, n a of t you can say that okay, 3 here, so 3 minus 2, that is equal to 1 here. Okay, so dimension of n of t. So this is, so these are the problems. So what we have seen with respect to the subspaces, the fundamental four subspaces, that is C of n of A means column space, n of A left null space, that is n A transpose, and row space, that is C A transpose. Okay, so these are the four fundamental subspaces and the problems on that.